If you decide to do the solids of revolution, which is option 3 in the enrichment activities, what you have to do is you have to imagine a two-dimensional shape, and we're going to graph these on the coordinate plane, being revolved in space about a specific axis, and in the process creating a three-dimensional solid. We're going to watch this video that illustrates that with a couple of functions. So first it's going to graph the square root of x, a function that you're going to become very familiar with in Algebra 2. That is that graph of the square root of x beginning at 0, 0. And they're going to graph a linear function y equals 1/10 x just in that first quadrant. And they are going to graph the vertical line x equals 4, creating what we call a bounded region. That red region is the bounded region that they're now going to revolve about the x-axis, creating a three-dimensional solid. And you can imagine it creating a solid as it revolves through space, or pulling out a disk to show you that there's a hole in the center created that by that function y equals 1/10 x, which created that gap. And that is a solid of revolution that is animated. Now, what you are going to get is you're going to get a graph, and I'm not going to give you an equation, although I could say the equation of that linear function is y equals -3/4 x plus 3, and I'm going to bound it by the x and the y-axis, or x equals 0 and y equals 0. But for our purposes, we just need to know that we're going to revolve that triangle either around the x-axis or the y-axis. So let's say I revolve it around the x-axis. If I do that, this line now becomes a circle, and I end up with a cone as a 3D solid. And now that I know that I have a cone, I know how to find the surface area and the volume of a cone. Remember, surface area of a cone is going to be pi r squared plus pi rl. And of course, I would have to do the Pythagorean theorem, 3 squared plus 4 squared, and it would end up with 5 for this length right here. And the radius of this cone is 3. That's right here. 3, radius is equal to 3. The height is equal to 4. I could calculate the surface area and the volume of a cone, 1/3 pi r squared h. Okay. So I could do that. Now, I don't have to revolve around the x-axis. I could also revolve it around the y-axis. And would that make a difference? Let's see. Let me get rid of what I don't need. So now, instead of revolving it around the x-axis, I'm going to revolve it around the y-axis. So what it's going to do as it revolves around the y-axis is now it's going to create that circular base right there. Didn't do such a great job with that. Let me try again. So it's going to create the circular base right here, and it's supposed to be creating a nice pretty little ellipse for you, but it's not doing it. Let me see. There we go. It's a little bit too big. It's really only supposed to stretch over this far. Don't know why it did that, but I suppose that's user error. So what it does is it now creates a cone where the radius of this new cone is 4. That's right here, 1, 2, 3, 4, and the height is 3. And you could calculate the surface area and the volume of this cone. Doesn't have to be a cone, let's say, and it could give you the linear functions here. X equals 0 is the y-axis, x equals 4 is this vertical line right here, y equals 0 is the x-axis, and this line right here would be y equals 2. So I could give you those functions, but instead I'm just going to tell you we're going to revolve this rectangle around either the x-axis or the y-axis. So first let's imagine it revolving around the x-axis. If I revolve it around the x-axis, I get a circular base here. I get a circular base here. Can you picture what this is going to be? Boy, my ink to shape is not working very well, and clearly I'm not good at drawing these ovals. So there's a nice pretty oval, but it's not the right size. Let me change the size a little bit. That's a little bit better. So Let me see if I can do a better job on this one. So can you see that it's going to create a cylinder? And I have to move that up. It is pretty, but it's out of place. So it ends up creating a cylinder. And if you look at the circular base, the radius of this circle is 2. The height of the cylinder is 4. I can calculate the surface area and the volume using my formulas. Surface area is 2 pi r squared plus 2 pi rh, and that the volume is pi r squared h. And I could read the radius and the volume. The radius is 2, the height is 4. What happens if, so I'm going to write those down. The radius for when I rotate it about the x-axis, the radius is 2 and the height is 4, and I can plug into those formulas. What happens if I rotate this rectangle around the y-axis instead of the x-axis? So now my axis of rotation is right here, so I get a base right here. That's definitely not going to turn into a pretty circle. Let me try again. Will that turn into an oval? Is that close enough to an oval? We're going to have to take that as a, okay, I'll take this one. I'll just resize it a little bit because the size is off. So it does create a circular base here. It is going to create a cylinder again. I'm actually going to put the pretty one up here. And so now you can see that we have a cylinder, but now the radius of the cylinder is going to be 4 and the height is going to be 2 because we've rotated about the y-axis instead of about the x-axis. Our axis of revolution is the y-axis. So radius is equal to 4, height is equal to 2. And I would get a different surface area and volume because of it. So there are a couple other things that I can show you, but I tried and I can't move off of this screen without, it doesn't work. So hopefully this helped, and if you decide to do the solids of revolution, that is what you will be working with. There are a couple problems that are slightly more challenging than this, but if you need help, you just have to ask.